Hello and welcome to this section, Creating Modules and Plugins, followed by the first video, Creating Modules. In this section, we're going to take a look at creating modules. Then we're going to look at creating plugins. In this video, we'll start off by downloading the Ansible source code, and then within that, we'll make use of the developer hacking tools to interrogate modules behind the scenes. We'll look at the structure of modules and how within a module you report success and failure. We're then going to build a simple ping module using Shell. After that, we'll then leverage the Ansible module framework, moving our simple ping module to Python. Lastly, we're going to see how we can make use of debug information for failures. Throughout this course, we've used a variety of modules. Now, let's take a look at creating our own. Whilst the topic of creating modules might initially sound challenging, it is quite simple and can be done so in any scripting or programming languages. There are some advantages to using Python, which we'll cover, but let's get started by having a look at a simple one. Let's make a module to do an ICMP ping. The ping module that already exists inside of Ansible is an Ansible ping, i.e. a connectivity check. What we're going to do here is a network ICMP ping, and we're going to make use of the Linux ping command to bootstrap this. A good way to start our Voyager discovery is by looking at some modules. There's a great tool in the Ansible source code which is useful for this. Okay, so what we're going to do is we're going to go to our default home directory, and then let's clone the Ansible source code. This can take a while to run, and for the purposes of the video, I've sped this up. Okay, and then we're just going to do a cd dash to go back to where we were. We're going to be using the test module, which is in the Ansible source code. If we take a look at this, this specifies Python as the executable. In our case, we're running in a container which is intentionally lightweight, and we have user bin Python free. So we'll update this so it works in our environment. Let's have a look at one of the modules in the Ansible tree. We'll pick the command module, which as the name implies can be used for running commands. And we'll use the test module to run this. We're going to give -m for the module. And in this case, we're giving the actual source code of the module. We're going to go into the Ansible source tree and find the command.py, which is the source code for the command module. And with -a, we're going to pass some arguments. So we'll keep this quite simple and we'll have it request the hostname of the system. And if we run that, you can see there that this has worked. We can see the output, i.e. the hostname of the system, which in this case is Ubuntu-C. Some other things to note in particular, the output is JSON, and within this are changed and RC. Let's see how this differs if we run a command that doesn't succeed. So we'll bring up the previous command, and we'll just change this to XYZ. Okay, so again, the JSON output, this time, however, for a failed attempt, we have failed, message, and RC. Now that we've seen this, let's look at how we can mimic the JSON in the most simplistic of ways. We're going to use a bash script for this. A module can be written in any language, and the most important aspect is that it adheres to the expected JSON output. If you take a look here, we've got a file called icmp.shut. This is quite a simple shell script, and if we run this, you can see there that it gives a JSON output with changed and RC for the return code. And if we go into revision 2, and we take a look at the version here, this one has been changed, so it's actually got an error there where it's going to be trying to ping 128.0.0.1 instead of 127. And if we run this one, it takes a little bit of time, but you can actually see there that this has failed. Okay, so if we go into revision 3 and we take a look, this is back to the original version. So what we're going to do now is we're going to use the hacking test module against our custom module here. -M for the module. And then if we press return here. Okay, great. You can see that that has worked as expected with the Ansible test module utility. If we go into revision 4, this revision has been changed so that we can accept parameters. I want to bring your attention to the source line. Ansible modules expect all of the variables to be passed as a file, which will appear as the first argument to the script. When we use the test module, it does this automatically for us. So what we're doing here is sourcing the contents of that file. This way, when we pass in a parameter of target, it will become a variable in the script. We're checking to see if target has been set. If it has, we'll use the value. Otherwise, we'll default to 127.0.0.1. We also have changed the ping so that now it's using our target variable. Let's try this. Okay, great, that's worked as expected. Let's actually try this with a target. So we're going to bring up that previous command. Then we're going to do -A, and we're going to specify the target as CentOS1. Okay, great, that's worked as expected. Let's actually try this with CentOS4, which we know does not exist. Okay, great, and that has failed to ping. So this is coming along nicely. You'll notice on the output that it's saving the generated source to /home/ansible.ansible_module_generated. It will also be saving the generated arguments to a similar file, which would be /home/ansible/.ansible_test_module_arguments. Let's take a look at these files. Okay, so you can see there that we've actually got our script. And you can see there at the bottom that we've actually got our arguments. We can even use this ourselves if we desired, mimicking exactly what the test tool does. This explains why the source command works from a bash perspective, as we're essentially passing in a file name to $1, and the source command is being run against a file name. The next thing we're going to look at, Ansible will look for custom modules in a directory called library relative to a playbook, if it exists. Let's take a look at revision 5. And if we do an ls here, you can actually see that we have a library directory. Within this library directory, we have our ICMP module, which has been renamed so it doesn't have the .sh at the end. If you check this, it is exactly the same file. Okay, and let's take a look. We've also got a playbook in this directory. And this playbook is using our custom module, which is relative in the library directory, and it has a target there listed of 127.0.0.1. Let's give this a try. Perfect. Okay, you can see that that's actually been successful. Everything has actually been able to ping itself from a network ICMP perspective. In this directory, we also have a version which will fail. And again, you can see there that it's actually trying to ping 128.0.0.1. Let's try this out. And there we have a failure as expected. So with this, we now have a good understanding of how modules work. Let's have a look at how we would go about doing this in Python. There's a variety of benefits for doing this in Python, so to summarize, we get a lot of templated code for free, for example, command line arguments and output. We get templates for documentation, allowing the module to be documented and used accordingly in Ansible, i.e. with the use of Ansible-doc. If we want to publish the module to the Ansible source, it will fulfill the requirements that the upstream requires, and we can also use other Ansible modules within our module, for example, the likes of command. If we navigate to the following URL, this gives us a starting template, and I've used this and have put it into a file called icmp.py in the next revision, revision 6. If we take a look at this, you can see here, we've taken that default template and this has been updated, and within this we've added documentation with some example uses. If we go further down, we've updated the arguments, putting in target as a reference. This bit here is the actual payload where we populate ping_result, and here we're populating result with the output, specifically the return code and the run command result. Lastly, I've added a debug key here for debugging purposes so that we can see the outcome from the ICMP ping command. Whilst knowledge of Python is desirable, you can see that with a starting base, we are able to do a lot with a little Python knowledge. If, however, you are going to dive into creating both modules and plugins, learning Python is a very good route. Let's try out the module with a success and a failure option. Okay, so that was a successful execution, and you can actually see there we've got the addition of the debug output, which shows the output from the ping command. And then if we run this again with a failing target, you can see again we've got the debug output, but we've actually got a failure there. We've got failed as true and changed as false. There's also the message of failed to ping. Okay, let's go into revision 7. And in this one, we have the same file, but it's been moved to library. And From this revision, if you actually try the successful and the failing playbook, we can actually see that actually shows there as change. So this has been successful. And let's run the failing one. And in this one, you actually get to see the benefit of our debug statement. So where it's actually failed, you can see the output from the ping command. Lastly, another advantage of this is the documentation correlation. If we were to do Ansible-doc with -M and library, and we specify the module that we're interested in, which is ICMP, you can see there that we've got the documentation that was added to the module. Okay, great. So if you've got this far, you've really dived into Ansible in a big way. Let's look at how we can create plugins in the next video.